That's our North Star. NetDevOps is the result when all processes in network development operations are consolidated and automated. That's what we want to achieve. That's a high goal. And we're just in the process of doing that. And let me show you what influences our IP transport. Thank you very much. Our IP transport ODM architecture. An ODM, or an operational domain, is a confined set of services and systems that are necessary to fulfill a network, fulfill the service that this network offers, and can be combined together. So within an ODM, you see things like the network resources, of course. They're the heart of it. The service edges in the metro, in the data center, in the core, on top of which we have a resource fulfillment layer. And for that resource fulfillment layer, we do use NSO. Then we have inventories. We have inventories for the services. We have inventories for the resources. We also have assurance for services and resources. And then there is a service orchestration layer. A particular aspect of resource fulfillment is rollout, and I think it warrants actually a dedicated box in this diagram. And at the bottom, the heart is the life cycle, actually. Life cycle is really key. It governs the delivery process of a feature from engineering to testing to rolling it out in the live network. We need a good test automation process, and we need a continuous integration and deployment pipeline. So delivery stages that feed through the entire process to being able to see the infrastructure as code. We are really trying to implement what has been used in IT and bring this into networking as well. Everything is bound together by a message bus, so the individual system can exchange messages, and on the top we have an API layer for the northbound systems to interact with this ODM. All right, so that's really what we are working on today, and I would like to tell you that story from the point of view of these different people that I've shown up here, to give the different insights and views that these different people had, and that really explains how we came up with all of that. Let's start with myself. I have a background of a development engineer. Used to work as an engineer for a long time, so I was really shocked by our slow development cycles. Everything is so slow, everything is so expensive. We really need to simplify and streamline our development process. Maybe this sounds familiar to you, but let me explain how we develop something new today. So a network engineer sits down on the console, writes a piece of configuration, and eventually compiles that into an engineering manual. That's a Word document most likely, or a wiki if we're a bit more modern. And then goes to the software engineer who reads that manual, tries to write a config template out of it, and write an IT specification, maybe another Excel file, then hands that over to some external software developer who sits down, finally writes a piece of code and delivers that to Swisscom. Okay. Then the software and the network engineer, they sit together, maybe they don't. They test that manually in the lab and then most likely figure out it's not exactly what we wanted. So back to day one, and it all starts all over again. Finally, when they're happy, that piece of code can be deployed and the network can be updated. It takes ages, let's say at least 9 months, and it costs a fortune. So we have to change that. We want to change the way we work, the way we develop, and we need another job profile actually. We don't have network engineers and software engineers anymore. We need to have DevOps engineers who are able to do a bit of both. Of course, you still have to be able to develop your router configuration, but you also have to be able to, write that template and that bit of glue code that is necessary to bind those things together. Really developing as a former network engineer, now a DevOps engineer, the basis for resource fulfillment. Not the entire tool chain, right? But really what the network engineer is capable of doing. So we can iterate through that. We can commit the code and an automated test pipeline is run. We use Git, we use Jenkins, and this pipeline automatically tests the features that we are developing. Once we're good, we can deploy that code, the live network is updated. NSO is really the framework that allows us to do that, to change the way in which we develop, in which we operate our networks, because it's exactly a framework that is well suited for the network engineers with a bit of, say, programming skills. So we don't have to fundamentally change the way we work. We can already use the skills that are already present. Okay, so that's the development engineer's point of view. Now let's go to Vince. Vince is our head of operations and site reliability engineering, and he has a focus on assurance and network observability. He's got a lot of pressure from our top level management. There are just too many incidents after change. And he knows that we do not really know what the status of our customer services are. So what was the status before the change and what was the status after change? If you don't know that difference, if you can't tell, then it's very difficult to say whether a change actually did something or wrong or right? It's very often that our customers have to tell us that we did something wrong, and that's a bad thing. So he thinks that yes, automation is key. We have to automate, but if you do automate a mess, you will have an automated mess. So you have to clean up things first. So Vince came up with his journey for operations. We are now in a more or less manual operations where we do, say, ad hoc scripting, operations on a per device basis, on a per team basis especially. So we have silo knowledge and low standardization. Every team develops their tools by themselves, and they look completely different and don't interoperate. So next up is, say, an automated workflow, where the focus is still on troubleshooting. So we do prepare the changes well in advance, try to think of all the different outcomes that it may have, but in the end, if it doesn't work, then we'll have to troubleshoot after the change. Yes, we do a bit of hardware and software homologation. We do have a bit of tests that are automated, but in general, it's troubleshooting after the change. So where do we want to go? We want to go to automate our tests. We want to see the network as a code. Yes, you can put all the configurations in Git, and that's already a good step. So you can see in your timeline what has changed. We want to move to, say, a more test-driven operations, where we, say, rethink troubleshooting as testing. We want to implement telemetry analytics and have an automated capacity management. The network as a service model. No, it's not quite there yet. It's a network service model. We're modeling the services. And the key point that he makes here is in step number 4, CI/CD operations. So moving towards that NetDevOps model. That's how we call our agile way of network engineering and network development and network operations. We introduced that pipeline for accuracy, for agility, to being able to fail fast, develop quickly, iterate quickly, so that we can also do a frequent deployment, but in small chunks that are controllable. And we also want to implement observability, metrics, live tracing, logging, that we really know what the network is all about. Finally, and that's Vince's dream, is the outcome-driven operations. So driven by business process orchestration, where he, as a head of service reliability engineering, can say, yes, my network has been engineered to that level. We have these objectives, and we can actually make use of our air budget. We haven't failed this month yet. Okay, maybe we can be a bit looser on the next change. We also want to integrate our customer care feedback into the loop. So if customers are happy, that's great. And we really want to get that feedback from the customers. So effectively making usage of the error budget, as I said, and to manage dependencies and separation concerns is also a key aspect that he mentions here. And that management of dependencies and separation concerns really reflects well with the concept of an operational domain that we're seeing in the slide before. All of that is based on a foundation of, first of all, people in operations with a focus on reliability and value for the customers. But I would like to add here that they need to improve on their skills to combine IT and networking, which is obviously to you in the audience, but that's a necessity for the network engineer in the future. Then there's the aspect of processes, NetDevOps, network reliability engineering, and finally technology with test automation and CI/CD pipelines, which will eventually allow us to do a service modeling and implement the network as a service approach. Right, Vince, thank you very much. So we've covered on the service assurance part. We have touched upon the CI/CD pipeline that is necessary. We have even mentioned test automation. So he's got quite a few parts of that big picture as well. Ente Panos, he's a system architect, responsible for a whole lot of things, but he has put a particular focus on the rollout process. Again, rollout process is done by every team on its own. Whenever a new device has to be put into production, that team comes up with a new process, how to bring that into the network. And every time it looks different. So he would like to design a rollout process that is generic and applicable enough for the whole network. So one process that fits them all. In order to simplify and automate the rollout process, that's it really. There's a lot of efforts that are put in on-site engineering by the field service personnel. We want to reduce that to the maximum to make them efficient as possible, and to decouple the work of that field service engineer from the back office engineer. When you have to call somebody in the back office, please enable that link, and then wait on the phone for 10 minutes, that's just not efficient. They should have a tool where they can go through that process automatically, not having to call anybody else. So what is a rollout process? Of course, on day minus 2, there's always that planning and outlining of where that new device has to be put. Of course, that can't be automated, frankly. I think there's always a human being in front who has the intelligence. Yeah, I'm going to place that device here. Those will be the 2 uplinks to that device. Yeah, right. Then on day minus 1, that's usually where you have to put some pre-configuration onto a device. So something that you have to roll out, that you have to put onto the device before you can actually roll out. Just the minimum configuration that is necessary to be able to talk to the device once it's on site. We want to reduce that to the maximum. Actually, we think that it's not necessary at all to do that, as we want to use zero-touch provisioning for all new devices. In order to use zero-touch provisioning, the network must offer a few services. The uplink devices, they must be configured in such a way that they support the zero-touch provisioning process. And that, of course, is done by our resource fulfillment engine. So NSO is triggered by a process workflow engine to reconfigure the uplink devices only temporarily, that they do support the zero-touch provisioning process, Then the device can be connected. It will acquire a temporary IP address, a firmware upgrade is done, and then it's now ready to receive its actual base configuration. So NSO can contact it. It will deploy the base configuration to the new device. NSO will change the management IP address from the temporary to the permanent one that it has just configured. So it's important that both of them can be reached at the same time. And finally, NSO will then remove the temporary configuration from both the new device and the existing uplink devices. We're still working on that. This is a plan. It's not yet in production, but we're getting better at this every day, really. Now let's take a look at that base layer here. And here René is our evangelist on delivery methodology. He's from Cisco, a really good guy, and he told us how we should do that delivery process, how we should do testing, how we should do that CI/CD pipeline. And bear with me, it's going to be quite a complex slide. I'll talk you through it. So let's keep it simple at first. At the top, you'll see the delivery process, and at the bottom, 2 sample domains, 2 sample environments, really. So let's start with the development part, which is the first half of the process. So you'll see in the delivery process that we have features that are in the solution backlog. One by one, they are pulled and taken to development. So there's a high frequent development process where we commit, where we test, where we commit again, where we test again, and this is then reflected down here in the individual environments. There are 2 examples here. One test environment for, say, the IP transport operational domain and a B2C services operational domain. Can be anything, really. And in here we have 3 stages. So first of all, the individual developer's laptop. Everybody can develop as they like, really. Whatever suits your personality best, that's okay. We can have a very individual setting here. Once it's committed into Git, a automated pipeline is run, which we call dev test lab. And you see it consists of everything that is required for at this point in time to run unit tests. Here everything is virtual, but we have a dedicated NSO instance, an assurance stack, a transport network stack. At this point in time only virtual, so using NetSim devices. And whenever you commit, then unit tests are run here. If those unit tests are okay, then the code is automatically promoted to the integration lab stage. Now the integration lab stage has a physical network because we want to test very early whether it also works on actual physical hardware. And so everything that is in here is also duplicated in that integration lab domain. Other domains are simulated, stopped, mocked as required. It's really a frequently updated test setup here, multiple times a day whenever new things are committed. Now, once the code reaches a certain level of maturity towards the end of a sprint or the end of a PI, then a human being, our environment manager, promotes the code to the end-to-end lab environment, which is yet another completely separate lab environment with its own set of network, assurance, fulfillment stack. Everything is also duplicated there. The idea is to keep those lab stages identical so that we do not have to worry about which test can we do in which stage of the lab. They should be identical as much as possible. And it's quite an investment at first, of course. Now here in the end-to-end lab, we actually test the integration with external systems. So external northbound IT systems, for instance, and of course they do require that the actual code in here is stable. So this is not updated a lot, but actually exposes the API to the external systems. Finally, before we go to production, we push the code to the pre-production lab, yet another stage. Honestly, we haven't built that one up yet. We're still working on it. But the idea of that pre-production lab is to have an environment into which we can develop a bug fix, for instance, without having to revert everything that we had in advance. So if you see, okay, there's something that we have to urgently fix in production, let's develop it, push it right to the pre-production lab, and if it's okay, then we can go to production. We have our change board. It's a bit small here, but this is a board of human beings who actually give their go for a change to be pushed into production. And you see how only here everything does come together, so the different stages of different ODMs. We do test interworking on the end-to-end lab and the pre-production lab, and in production everything comes together. So thank you, René. That's really complex, but I think it's a great setup. Finally, let's take the hat off Rudolf, who's our solution architect. He has the big picture. Rudolf read telemanagement forum standards in detail, and he thinks that TMF definition of an ODM is a good way to structure our spaghetti of networking and IT that we have today. So every ODM should have their DevOps expertise and responsibility. Continuous integration and deployment pipeline should be built per ODM. People are assigned to an ODM. Teams are assigned to an ODM. Resource, service management, everything is done per ODM. So within an ODM, an operation domain, there's a high cohesion. Externally to that ODM, there's a low loose coupling. So we do expose a few APIs, but the entire complexity is hidden within that ODM. We can also separate release cycles of each element belonging to an ODM. And the release cycles of various ODMs don't have to depend on each other. And you see in his slide as well the importance of that automated lab and tool chain. This is really something that he also notices that this is key. Finally, having all these different operational domains in place, that allows you to implement that network as a service approach. So network as a service really governs a set of ODMs at the bottom, using always the same approach with that automated lab and tool chain and automated testing, whereas the NAS layer exposes the service level API, the ODMs expose the domain capabilities towards the ODM. And the ODM is the NAS layer is the service point on which we can then integrate OSS and BSS systems. So now we've seen all the different approaches and ideas that governed our ODMs, and I think we're getting there. I mean, we haven't reached our North Star yet, but it's a process, and we're happy to have finally started on that journey. So, thank you very much.
So thank you, Martin. It's an impressive work that you have done. So when did you start this?
We started 3 to 4 years ago to develop the ideas. It's quite a journey, yes.
Yeah. Did you have to recruit people to do this, or did you train your own staff?
We did train our own staff, yes.
Okay.
And we're still in the process of training our own staff. So I think this is key. We have a lot of help from Cisco. Thank you very much. But the idea is really to be able to stand on our own feet and being able to do that on our own.
Yeah. I know you have a big team in Bern now, actually attending a satellite event to this. So the team is joining the virtual event, and then they have some additional workshops with CX, and it's an impressive team. So great. Do we have any questions from the audience to Martin?
In fact, that was an intermediate step. Today we don't do that anymore. I think it's a first step, you know, to save plain configuration in Git, and then it's just a text file, to be very honest. But now, as we use NSO, it's actually the templates and the NSO's Python code, and so that's what we store in Git. And the generated configurations are then a result of it. And we do not store that in Git anymore, but the actual code that generates it.
Yeah, you have a microphone there.
Oh, thank you. The second one would be regarding the unit test. I don't know how you're mocking all the map APIs in NSO, if you can share that for the unit testing part.
Sorry, I didn't get the question.
For unit tests on your pipeline, I just want to ask you how you're mocking the NSO APIs for unit tests, or if you are mocking for unit tests.
Honestly, I'm not a specialist, but I don't think that we are that we mock NSO. We really deploy NSO for every test run. We're using a Docker container that is built every time we run a new test, at least in the first pipeline. And then NSO is built. All the necessary, say, models, NAD services are downloaded and installed, and then the test is run.
Got it. Thank you.
Okay, do we have one more question that we have time for? Yeah.
How do you deal with the regression testing today?
Yeah, regression test. I mean, that's really the key, that we test everything all the time. So we don't really do a particular regression testing, but we have this pipeline that runs a set of tests all the time. So we can call that regression testing, but I think it's more a continuous testing, really. Does that answer your question?
All right, thank you.
Okay,
right.
Thank you, Martin.
Thank you very much.
I'm sure that you will answer any question if people come up to you during the day. So
Thank you very much.
Thank you.